Hey, so I want to go over the two drag racer problems, just one after another. Hey, the first one where it's speeding up, we certainly know that that means that it is not at constant velocity. The speed is certainly changing. And if it's not at constant velocity, that means our sum of forces is not equal to zero. So we have our force diagram, we'll have gravity down. I'll leave the suffixes to you, or whatever the subscripts. Force normal up, and we have kind of this big frictional force, on the drag racer with the ground, because they have those giant sticky tires back here. If you've ever seen a drag racer in slow motion, you see just how sticky and how low pressure they are, just to get the most amount of grip they can. Hey, position versus time. On this one, the idea was only to just do it qualitatively. And let me do that a little bit better. Hey, so we know position versus time is not going to be a straight line because it's speeding up. We saw that from our very first walking around lab, that if we're speeding up, we end up getting a curve upward. Okay. Our velocity, just a note on this one, you were asked to do it quantitatively with numbers. I'm just going to do it qualitatively. It's moving fast at a very high speed. By the end of the video, it was going at a slower speed, but still forward, so therefore the velocity is still positive. So now let's take a look at that second condition when it was slowing down. It's past the finish line, and they want to get slowed down quick because they're going really, really fast. They don't want to run into the end of the track. So because we're slowing down, our velocity is not constant. Again, not constant velocity. I'll just put CV to abbreviate that. So we know that the sum of forces is not equal to zero. They are not balanced. Okay, in this case, we know that we're going to have gravity down, gravity, we're going to have normal force, the earth in there. But we're going to have frictional force with the tire, and then this parachute is interacting with the air, and it's going to create tension on these cords that hold it to the back of the car. So your force diagram, we're going to force of gravity on the dragster from the earth, a force normal on the dragster from the ground. We're going to have a frictional force on the dragster from the ground, and then that parachute from that tension force with the cord is going to produce another force on the dragster, from the parachute or the cords, depending on if you want to consider the cords part of that parachute, you can put parachute, cord just separate, do something different. But again, we can see how is it not balanced. Hey, there's nothing over here. Right now, hopefully this guy isn't stepping on the gas. He's just trying to get it slowed down. This is our unbalanced force. This and this cancel, so we're slowing down really fast because our force is in the opposite direction of our motion. We're still moving forward, but we want to move forward less quickly.